Unpeeled. And today we've got some news for you today. Let's see if I can pop this up. Yeah. And we've got some news for you today. And well, the first news is actually it's a breakthrough in metal 3D printing technology. This is a Korean metal 3D printing technology, and it comes to us from Dr. San Woo Song, Chan Kyu Kim, Kang Mung Seo, at the Department of Joining Technology, the Korea Institute of Material Science, the KIMS. And they worked together with Professor Young Tae Cho and Professor Seok Kim at the Department of Mechanical Engineering at Changwon National University. And they also worked with another research team led by Dr. Chanwo Cho of Busan. A lot of people involved in this project, and well, it's pretty logically, well, it's a pretty logical thing, really, if you see what it is. So essentially what they've done is they've managed to make a arc plasma-based welding technology, or 3D printing welding technology. Now, we already have DED type of technologies. Generally, they will either take blown powder or a wire. They'll melt it generally using a laser of some sort, or multiple lasers maybe, and in an open air usually. Well, then, in the case of WAAM, on a robot arm, for example, build an object. Now, these technologies are very inexpensive because they're very inexpensive. They can make very large objects. They're not very call it like sometimes jokingly we say like nowhere near net shape or not near net shape because a lot of these technologies, well, they look very rough, and also the control over the parts is a little bit limited. So it's pretty difficult to make something that you this complicated to make, and it's pretty difficult to make something that you have such little control over. Now, so what these guys did is they've developed a different technology which uses an arc plasma power source or heat source, and what they're doing is a continuous droplet technology. So rather than waiting for this droplet to cool and then dropping another droplet somewhere, what they're doing is they're depositing this thing using the controlling the volume very, very tightly of these droplets, using the surface tension of the metal to optimize the cooling, so then add droplets to it in a continuous way. So they say that they have like a near layerless technology, right? And this means that they can continuously draw in a really, really very, very specific way, very programmable way, drop these droplets to make these structures. Now, this may mean that they have very less layers. That may mean that actually the adhesion, the layered adhesion is better. And what they're saying already is that some of the mechanical properties and the properties of parts are better. So because of this, one of the things they're saying is that compared to WAAM parts, the ductility is over 24% higher. So you could get better properties. Now, generally, they also, like really confusingly, call this a metal 3D printing pen. And I guess the analogy is there to see this as kind of a pen. But if you look at it, they mounted it on a robot arm. And this is not, well, this is maybe is a metal 3D printing pen, but it's probably not going to go to be held in anyone's hand anytime soon. But it could be to repair structures and stuff like that. Something like this would be very interesting as well. But it's really what they're doing right now is mounting on a robot arm, and they're building objects. I think this has huge potential. It's a completely new, or it's a new technology. It's a new development. It's different than everything we have at the moment. It's similar to some other things, but it's always wonderful to see things. And also, it's wonderful to see the news coming out of Korea, because Korea is a very advanced economy. It's one of the richest countries in the world, one of the largest exporters in the world. They do a lot of shipbuilding, a lot of chips, a lot of very advanced things. And there's some 3D printing players from Korea as well. But so far, the country has not really come to 3D printing as some other countries like Germany, for example, have. So it's a great to get together on a project like this and develop a technology that has a lot of potential. And especially if they, if the cooling patterns, and if they control this very, very tightly, they could have a technology that potentially could build structures in a very, very rapid way, very, very inexpensively, and make them very, very large. So that could be super exciting, I think. And now, and it's a similar technology to some, such as the Vader things are kind of similar, but it seems to be that it's a completely new IP stack as well. So that in and of itself is super exciting as well. The next news is by Mania Aghaei Meibodi and Alireza Bayramvand and Yuxin Lin. They're at the University of Michigan, the Taubman College of Architecture and Urban Planning. And what they've done is something that is really, really smart. What they've done is they've reduced the weight that 3D printing concrete, or weight and waste that 3D printing concrete produces. So by as much as, in some cases, 72%, by a shell wall method. Essentially what they're doing is they're using topology optimization to optimize shapes, put strength or design shapes that the strength is only required at certain locations, and then using a non-planar toolpaths and a variable material deposition strategy. What they're doing is essentially just tightly placing concrete where it needs to be. So this could potentially be really, really advantageous to 3D printing concrete, because it could make it much more environmentally friendly, and it could also make it much cheaper as well, and much faster. So it's a great development. I hope that they get to commercialize this or something like that, because this looks like it could really be something very, very viable and very, very handy. And here you see that there are some, not without distortion, but some quite large, quite interesting structures already to demonstrate what they're doing and how they're doing it. So that's very exciting. Now, earlier today, I was reading patents, and I was reading there's a patent by a company called Edwards Life Sciences Corporation, and they are a company that does artificial heart valves and catheters, that kind of thing. And it was a patent for a perfusion balloon. It's kind of catheter you essentially will put it in something and then open an artery or some other thing to keep it open, or to kind of stretch it a little bit more for whatever reason. Angioplasty is one of the things. A lot of other things in not only cardiology stuff, but also in other areas, or use similar balloon catheter type of devices. Now, in that patent, they mentioned that the mold for this very special balloon catheter could be made using 3D printing or other means as well. And I thought that was very interesting that they mentioned it. So first off, maybe it's a patent, so maybe they just put 3D printing in there for no reason whatsoever, right? Because they just want to cover all their bases. Like, these patent language is a bit kind of weird, and they try to always be inclusive. Like, maybe it's made with this, maybe it's made with that, or maybe it's made with the other thing. They do this to kind of like obfuscate what's really going on sometimes, and oftentimes just to be sure, just to cover the bases that the patent isn't only for laser cutting molds, but it's also for 3D printing them, for example. So maybe it's just that. Maybe that's the only thing that's going on here, and that's what the company is doing. Could be. But I still felt a little bit kind of triggered by this, inspired by this, because they were mentioning that beryllium copper molds or other copper alloys. So beryllium copper is a alloy that is very advantageous for molds. It's got really great thermal conductivity, much better than other materials and other coppers, and that means that you get a lot better cycle time. And the cycle time, of course, in molding is important because, well, you can make more of something in less time, essentially, if you have a faster cycle time. There's also some others. Beryllium copper has better corrosion resistance than some other materials as well. Now, it's very common in the mold and die industry, but so far it's kind of difficult to handle as well. So beryllium copper is something that we really mastered that much, or at least I thought we didn't. So what I found out, and when I went through this internet rabbit hole thing, is that there's a company called Materion, kind of a metal company that do a lot of stuff in beryllium, and they appear to have 3D material with copper in it, which I think would be super exciting, and I did not know. And the thing is, with material also is another specialized material, which is in nuclear, space, very, very exotic, very high type of things. So this is a fantastic use case for 3D printing, but of course this material is really difficult to handle. Now, generally, what I was like, oh my God, what a fantastic space for 3D printing to make metal medical device molds. Now, this is not something a lot of people are focusing on. Some people, more and more people, are working on medical device tooling or medical device end use products as well. But medical device molds to me is an absolutely fantastic application where you can then copper or another material and then do the cooling, improve the cycle more. Fantastic application. So this is kind of a random bit of like news from this patent, but I thought it was really exciting to figure out that maybe thanks to our company we have copper material. And also medical device molding is an application I haven't heard about. Of course we know it exists, but for these really tiny, highly accurate balloons, this is a fantastic application for 3D mold making for devices. Probably something that maybe people have been doing this for a decade or more. Maybe all these people are specialized in it, but it's just something I hadn't thought of before. So I thought it was absolutely fantastic to, envision a market for us for mold tooling for cathode components. So thank you very much for your time, Spiels, and I hope